Hi, John. Welcome to Venture with Grace.
Hi, Grace.
Okay, so to start the show, I would love for the audience to learn more about you. So you have started your career as a founder of a company, and then you work at AWS for over 9 years, and then now you're a partner at Madrona. Why don't we start with like what are some core lessons that you've learned early on in your career that kind of shape you into who you are today?
Core lessons in my career. That's a big one. I would say that, there are kind of two hands that I've had to use at different stages and different degrees. One is the hand of diving deep, and
Mm,
one is the hand of kind of peripheral vision. And I'm someone who believes you can't do only one of these things or the other. So as an investor, as a partner at Madrona, I focus on early stage AI companies and early stage data companies. And I don't think you can really make strategic or investment or building decisions without understanding how this stuff works, without trying it, without getting your hands dirty and building with it.
mm,
And that's, I've done that along the way in my time at AWS and in my time as a founder. Amazon was too smart to let me check in code, but when I was the CEO of a company, I was allowed to check in code. And so I was, at different stages, I used my left and right hand differently, but you got to have them both.
I love that. I actually have a question for you. So it seems like you studied finance, and then and then at AWS you were working on products. I guess like how do you apply, I guess like first of all, like you mentioned, since you mentioned about like gets your hand dirty, and then as a co-founder you would be able to like checking codes or like potentially even writing codes, but like how do you think about like as a non-technically trained person to like actually understand these like technical concept, what are some key things that you were actively pursuing to understand how to build a great product versus like I guess like from I guess like how do you leverage your non I guess like finance background to work on products?
Yeah, I mean, I've been writing code most of my life. I didn't study it formally, but since I was like 5 or 6, I was writing with Basic. And some people may remember something called Lego Logo, which was very inspiring to me. It was about, you know, uh, building Lego bots with sensors and actuators that you could program with Logo, which was a variant of the Basic language.
Mm,
This is something I've been doing for a really long time. And what has always excited me is the intersection of technology and history. We're building an AI right now, but if it were 100 years ago, I'd be building in railroads. And you'll see behind me maps of the transatlantic railroad and the transcontinental railroad and the transatlantic cable, the first
mm,
transatlantic cable. So this stuff is always very intertwined. Now, as far as how to build great products, it's very much the same thing. It's, can you understand uh, who is the customer and what problem she wants to solve, and therefore what should we build? And I'm somebody who over indexes on stories and on individual customers. There is broad data and the rest of it, but if I can understand that Grace is the CEO of Rio Tinto, who's using autonomous mining vehicles to do drilling and mining in West Africa. That helps me understand much more tangibly what kind of edge compute she requires, what are the latency requirements of it, what are the protocol requirements of it, all these things. And so I can make it tangible both to CEO Grace and also to my elite engineering peers.
mm. Love that. Okay, so to understand basically the end user, I feel like it's very important. And okay, though I have so many personal growth questions for you, but I feel like since we briefly chat about the, I guess like the applied AI side, maybe we could start there because I think that would be very interesting for the audience to know. So maybe we start with like what is applied AI, and maybe like we could start with like the agents stack, the new
Sure.
agent stack.
Yeah. So, well, let's talk about agents and what they are and where they're useful. We can get to the stack in a minute. Agents are, it's a very overused buzzword. Some people are saying we need a new one already, and we'll get to that, I guess. But It's nothing more than a loop of response and prompt and response and prompt at the most basic. But amazing things happen when you do that. And you're actually building an application on top of AI. You can compose these loops together, you can build workflows with them, you can guardrail them, you can integrate them with outside services. And when you do that, all of a sudden, you have a partner that can perform tasks and can interact and can be a thought partner. There are kind of 3 or 4 functional types of agents that I've thought about and that I hear people talk about. One is next generation copilots, and this is very similar to GitHub Copilot is something people talk a lot about. It works together with you, and it's kind of on the side of the screen. The metaphor of a copilot is really powerful there. The second is a teammate that will say, right, I'm going to go take this task off your plate, Grace, and I will come back when it's done. The third is what some people call an ambient agent that is working in the background. It doesn't actually have much of a user experience. If you've heard about these sort of inbox agents that are out there that actually go through Grace's entire email and prioritize what it is you should respond to and even draft responses based on your style and suggest actions and next steps and are working all the time. Some people call those ambient agents. And the last category is what I call agents as a service that are not, they are agents just like, their applications, just like anything else. But instead of being designed for end users, these agents as a service are designed for developers to compose into larger applications. And, when you do this, you can apply one of these 4 metaphors, one of these 4 application metaphors across almost any domain. I mean, really the whole world of software is up for grabs. Every single piece of software, when you think about it, is, I think Satya was making this point, Satya Nadella, you have a combination of data and workflow and user experience. And the user experience and the workflow are all of a sudden so much more flexible in this new world than they have been. The entire world of software is up for grabs and can often fit into one of these categories.
I wonder, okay, so I have so many questions there. So like if you listen to me furiously typing because I didn't connect to my microphone today, so you will hear me typing, but it's notes. Okay, so you mentioned about the 4 categories. One is like the next gen copilot, and then one is teammate, one is ambient agent, and then one is like agent as a service. From those 4 different categories for you, like how do you think about which one will be more profitable and then which one actually have investable opportunities? Because I feel like nowadays, whenever living in Silicon Valley, I mean, today I'm in New York, but like spending like technically, like, so as a person living in Silicon Valley, I only hear about AI agents and infra, and then today, we're talking about apply AI, and then whenever people define agents, like it's supposed to be end to end, like like you mentioned about the teammate version. I feel like that's the most popular version that I've heard that like AI agents supposed to do. But nowadays, I think most of them are kind of co-pilot. Basically, you gave them a prompt and then they do something, and then you kind of like refine the prompt, and then they kind of help you do something again. I wonder, through these all different process, I feel like in Silicon Valley, the most popular one right now is like when you talk about AI agents, like for example, legal or I don't know, like I guess farming or whatever, like it's just domain expertise agents. Can you talk about like, how do you think about which subcategory in these 4 category will be, I guess, like most profitable, or how do you think about the profitability or money wise, or like just anything
Yeah,
investor perspective?
I would answer this slightly differently. I would say that I would frame this slightly differently. I'll tell you that as investors, we think a lot about how to apply AI and data to our own work. and we're doing that aggressively. And so I've written some multi-agent stuff that actually helps me do my own job. And
Mhm.
at Madrona, we invest pretty heavily in that too. And we have this conversation. Okay, so how far will that go? Are we going to have agents just do everything for us, and we can go on podcasts 100% of the time? And the answer is no. I'm somebody who believes there is a very important part that is intrinsically human to my work, which is in venture the decision of where I should focus. What are
Mm,
the areas that matter? What are the kinds of companies, the kind of founders, the kinds of problems to be solved that demand attention? And that steering gets applied with more and more and more leverage. And we'll have a combination of co-pilots and teammates and ambient agents and agents as a service.
mm,
Now, if you want to look at where the opportunities are, there are kind of two axes to it. One is something that was spelled out really nicely by my colleagues Sabrina Wu and Vivek Ramaswamy. I'm pretty sure Vivek has been on your show too, Grace. And they've done a really cool blog post looking at the P&L of a company and saying, where does the people spend go, especially the people spend? And the more people spend, the more opportunity to leverage those people with agents. Okay, and it's a product of how many people times how sophisticated is the work being done.
mm,
So that's kind of one element to it. And you mentioned legal. Legal is a particularly juicy target because it is a highly uh, expensive, people intensive domain of work, highly sophisticated. Of course, you have to go to school for years, and you have to be really smart, and you have to pass the bar exam, and you have to be admitted to work in big law. And I think the industry in the U.S. alone spends something like $100 billion on big law attorneys every year. And yet, the industry was resistant to automation
mm,
until very recently because they could always hire more kids and make them stay up all night. And now all of a sudden those walls are starting to break down. And so what Sabrina and Vivek's framework does really nicely is help think about where that people cost is. And the more people cost there is, the more opportunity there is to leverage those people and make them more efficient.
mm,
You can think about that functionally, or you can think about that by industry. That's one. The second is as you creep up this hill from co-pilot to teammate to ambience,
mm,
and we'll say agents as a service are kind of under the covers. Co-pilot, teammate, ambience. There's a level of trust that you have to put in the agents. And the agents have to be trustworthy before they can be trusted,
mm,
right? And so they've got to climb up that hill.
mm,
And it's very natural to start with areas that have a lot of money flowing through them,
mm,
DTM, and also have a relatively low blast radius where, with a co-pilot, uh, if I, have a co-pilot in a GTM scenario, if the co-pilot suggests a marketing message that's kind of silly and doesn't make sense, nobody's going to get hurt.
mm,
And the more automated I get, the more conscious I have to be of the blast radius of what happens if something goes wrong.
mm. Um, so okay, let me repeat your first point, which is like, Vivek and Sabrina's article, which is like where most people are spending, it's like the more, I guess, human intensive an area is, it means like um, more opportunity there is for the agents. Okay, so okay, maybe we could talk about like I guess like in the engineering world, which is like the one that you're in. Why don't we talk about like what are something that developer in the developer community that you feel like is most like human intensive, and then where could be I guess like improved? Maybe we could use Bolt as an example, or any of your other portfolio companies. I guess, like, how do you apply this kind of framework to spot the company that are you feel like would actually have potential to take over a lot of heavy lifting, whether it's on code or any other um, things in the infrastructure or applied AI world?
Developers are in so many ways a really great playground for AI because they like new toys and because they're expensive and scarce. We don't have remotely enough developers. We're not even training enough developers to create all the applications that our economy is going to demand.
Mm,
So every developer that has an infinite backlog.
mm,
Uh, and this is going to continue. And humanity is really good at creating new problems. So this is only going to get worse,
mm,
and therefore have more opportunity. But it's really good because developers are also really sophisticated about taking suggestions and taking input and working together with tools that might break sometimes. And so they
mm,
can handle a wider blast radius.
mm,
And so if we break this down, there are examples of each of the kinds of things that we're starting to see. Copilot was first coined as a brand for GitHub Copilot.
mm,
And GitHub Copilot collaboratively writes an app with you, writes code with you
mm,
by going, way beyond autocomplete. It actually suggests blocks of text based
mm,
on your comments of what it is you'd like this next block of code to do.
mm,
And it's like a pair programmer friend.
mm,
And one of the really cool things about it is you can hit a button and flip through an infinite scroll of different alternative blocks of code that might accomplish the same thing. And so that's an example of the kind of boost of creativity that developers have gotten to know now for 2 years or more.
mm,
And so that's a Copilot. Cursor is something that's taken that to the next level. And for those who've tried Cursor, I'll say it's almost fun. It is fun to use something like that because it suggests just whole blocks, huge chunks of code that will accomplish the task that it is that Jon Turow as a developer would seek to create. And the nature of code is that it's so precise and exacting. You've got to explain step by step by step what it is you'd like to accomplish and do it in a way that is efficient and meets all the performance criteria you'd like to meet.
mm,
That is a very exacting process. And these kinds of co-pilot approaches make you more powerful because it gives you the ability to think at a higher level of abstraction and experiment rapidly.
mm,
These are examples of co-pilots. There are also examples of teammates that will take an instruction and just go off and work for a while and then come back.
mm,
One example of that is a company called Factory AI.
mm,
You literally grab tasks off a Jira and go off and come back and say, I did it. And this is categorically different from a co-pilot because it doesn't need to happen in real time and it doesn't need to happen collaboratively.
mm,
Instead, it can take its time. It can use all the reasoning capabilities that our underlying models are starting to offer that leverage the ability to take more time and
mm,
do that to come back and say, Grace, just like a junior developer might, Grace, you set this task, I grabbed it, I did it, I ran tests on it, and it works.
mm,
Now you mentioned Bolt, and Bolt is a really exciting company that I'm thrilled to be a part of. Bolt is an application from a company called StackBlitz that is mostly a teammate. You can call it either a co-pilot or a teammate, but I would put it in the latter category. you describe an app that you would like to build. And you do that with either natural language or a design. You can give it a Figma design or a picture. And you can say, there was an article in the New York Times late last week about Bolt and a bunch of other Bolt, Lovable, Vercel V0, a bunch of tools that can be used by professionals or by non-professionals in what Andrej Karpathy calls vibe coding. Because while you can look at the code, you don't actually have to. And so the reporter for the New York Times tested Bolt with an example. He said, hey, I'd like to have an app that lets me snap a photo of what's in my fridge and then suggests recipes that I can make based on the contents of the fridge. And guess what? It worked.
Totally.
He's not a developer. He doesn't have any development expertise at all. It works. And so this is really changing. I mentioned the problem that we don't have nearly enough developers to write the kinds of applications. This is changing that equation and flipping it on its head in two ways. Number one, it's enabling new people to become developers who haven't been developers before. And number two, it's unlocking new kinds of applications that probably never would have been created before. Kevin never would have created that app. Think about how many times you've created an Excel spreadsheet and you haven't bothered to save it, but you just did some stuff in Excel. And all of a sudden we're in a world where you can create apps that are disposable like that because the technology is so powerful. And having a teammate that will go off and do it gives you even more leverage to sort of request something that may not be all that earth-shattering, but can be really useful in a specific moment.
Okay. Is it okay if I share a screen of your blog or no? Okay, so share, present. Okay, slide, extra video, file, slides, PDF, image, just I guess, share a screen. Oh my God, I actually do not know what's gonna happen. Only the guests have shared screen before. So, you know what? Let me download this as a picture so I don't actually blow out my entire.
We're in new territory.
Yeah, we're in new territory. Okay, let me just slide PDF or image file. Okay. 1 sec. Yeah, I hope my desktop is more organized. Oh no. Okay, so this is not a picture. Wait, let me just screenshot this. So we have a picture here. I think it's a really good article, but I have so many questions. I feel like it's better to just present so the audience knows what's up. Image file. Okay, sorry, technical challenge every day. Okay, it's here. Okay, so I have a question about this. So maybe we could actually dive a little bit deep into each of the categories. So you mentioned there's agents, right? So the next gen Copilot, and then we just talk about Bolt, which is the agent teammates, and then there is the agent swarms. What is agent swarms?
Swarms are a really cool mode of agent applications where instead of building just one agent and having that agent interact only with John or only with Grace, you can actually build a collective of hundreds or thousands or more agents that interact with one another. And when they do that, you can simulate the behavior of large-scale groups. And you can use that, one way that there are a couple of companies listed here. Aru is one, Artificial Societies is another. They are using these swarms to create kind of a next generation Monte Carlo simulation.
What is Monte Carlo simulation?
Monte Carlo is an old analytics technique that uses random number generation and a workflow to simulate what's going to happen in lots of different outcomes. So think about, you may know Nate Silver's political predictions, 538. And what Nate Silver does is he collects all the polling data and says, there's a 58% chance that X is going to happen. And what he does is he knows that each of the polls have a certain probability distribution around them. And so putting them all together, he then creates a Monte Carlo model that that sort of rolls the dice a million times,
Mm,
and then creates a distribution and says, okay, well, the distribution of probabilities looks like X. It's
mm,
named after the casinos in Monte Carlo. It's meant to be like a dice or a roulette wheel, and it's a
mm,
powerful way of experimenting with the future. And just like Monte Carlo, nobody should be confused. Nobody should be confused that rolling dice tells you the future. It just tells you about probability and the impacts of probability. Agent swarms are taking that to a new level. They're not predicting the future. Agents are not people, but
mm,
you can put data and workflow around the simulation in a way that expresses a much more complex set of interactions than would have been possible to model with traditional software until now. And this
mm,
is applications in social media, in marketing, in political forecasting, in finance, in law, and policy, because the world is really complex. And if we can use AI to simulate what it might look like for lots of lots of people in a large group to interact, there's something to be learned from that.
mm. Very interesting. And what about maybe we spend a little bit more time covering the tools, the data, and orchestration, and maybe like we spend a couple minutes of each. Let's start with tools. So I wonder, so like since you mentioned there's discovery, there's agent as a service, and then there's like UI automation, secure tool usage, and browser infrastructure. And then off. Oh my God, there's so many. So let's talk about like how do
Let
you?
me let me frame this a little bit.
Okay.
Let me frame why this is important. There's something that history teaches us, which is
Mm,
that when you have new infrastructure, new kinds of applications emerge,
mm,
and those applications create new kinds of infrastructure. And I'll
mm,
take a really old example.
mm,
There was the invention of refrigeration. Okay, 150 years ago, whatever it was. The
mm,
invention of refrigeration was really important to the rise of Coca-Cola. Can't have Coca-Cola as a
mm,
mass market product without broad access to refrigeration. And so that is something that, if you think of Coca-Cola as an app and refrigeration as infrastructure, that's really powerful. But all of a sudden, once people start to love Coca-Cola, you
mm,
get new infrastructure requirements. You look for the invention of the vending machine and the freestyle machine and bottling trucks and all kinds of other things. And
mm,
once you have those at the infrastructure level, you can actually get new kinds of drinks and new kinds of products as well. Even some of that infrastructure was useful for, has been useful for delivering vaccines to patients. So there is an interplay between the applications that end users will take advantage of and the infrastructure that makes it all possible, back and forth, round and round. And this is the oldest story. And so something that I said at the beginning of the call is that it's really important to dive deep and understand how all this stuff works holistically.
mm,
And here's an example of what I mean, because as an investor and as a stakeholder in the ecosystem, I like to try to understand what the future is going to look like. And
mm,
so I look at the applications that we see, and I speak to hundreds of developers of agents, and I understand what it is that they're trying to accomplish, and what it is that they're needing to build in order to make that future happen.
mm,
And as we started to see a few patterns of agents come into view that are really exciting, Bolt went from 0 to $20 million of ARR in 8 weeks. And so there's a whole cluster of new companies that are trying to apply lessons from Bolt. And there are a few kinds of agents like that. Perplexity is another one that has lightning in a bottle. So as these applications come into view, the developers seek to buy versus build as much as possible of the underlying infrastructure. And so there is an ecosystem that has developed to support the functionality that those agent developers are going to need in order to invent as quickly as possible. And that's what I mapped this out for the first time a year ago when this was starting to, only starting to come into view. And as the application forms have solidified, the infrastructure has kind of solidified in a more coherent way as well. And so that's what I tried to lay out here. And there are 4 categories of infrastructure at the highest level that I see, Grace. One is called tools. And tools are all about expanding the capability of agents beyond chat. Right? If I want to do more than talk back and forth to an agent, I need to talk to the world outside. Tools are the things that let me do that. Data is just what it sounds like, using information to make the agents smarter and help them remember.
I have a question. Can we go through like what is a workflow to like understand this? So for example, let's say I'm a developer and then, there's like the agent that you can interact with, obviously, but like I guess like okay, if let's say I want to build a product, let's say I don't know, like I'm just using legal as an example, let's say Harvey, whatever. Like so let's say ChatGPT for legal. So how am I supposed to interact with the agents, the tools, the data, and orchestration and platform? So like maybe if you could like walk us through as like a workflow, if you're like building, let's say you and I are building this I don't know, either food recommendation system from the fridge, or we think about like OpenAI for legal. So how do we think about I mean not OpenAI for legal, like ChatGPT for legal, like Harvey or whatever. So like how do we think about like what is like the, I guess, different framework or like different things that we're supposed to do to actually put it together, and then how do we interact with the infrastructure stack to make it happen?
Yeah, so let's talk about this. The food recommendation app is a really interesting one because that was created by Bolt. So Bolt is actually doing a lot of the work, but it's nonetheless using this stack under the covers. Okay, so let's talk about it from the top down. Bolt is an agent teammate that the New York Times reporter decided he wanted to build an app that is going to take a photo of his fridge and see what's inside, and all of a sudden recommend recipes that will be compatible with what it is that he's got. Like he can make those recipes with the stuff he's got in his fridge. Cool. Okay, so Bolt is going to think about it, and Bolt happens to use Claude, which is Anthropic's model, and it uses Claude 3.7, which is Anthropic's most sophisticated model for code, among other things. Okay, and so going down from the top, we can think about all the different pieces that have to go into that. All right, now I need to be able to feed images directly to the model, and that's something that Claude supports out of the box. But I also need to be able to find recipes. And there are a couple of ways I can do that. I can use Sonar by Perplexity, or I can use Exa, or a bunch of other search tools to actually look for recipes, pages with recipes on them. I can, once I find those pages, I need to turn that into structured output. So I might use something like Firecrawl or Nimble to extract the data in a structured fashion that allows the agent to reason about it. I need to authenticate in this app potentially if it's not only for one person.
What authentication means? So like, sorry, what does authentication means? Is that just like, let's say, typically you type in your email and then it asks you for authentication code to your email. So let's say, hey, type in the 6-digit codes. Like, why is that? Just like, is that just for easy sign up?
Yeah, it's if I want to be able to prove that I am who I say I am, if it's important for this app that Jon Turow should have
Mhm.
access only to Jon Turow's stuff and nobody else should have access to it.
Mhm. Okay.
Authentication is the way we do that.
Yeah.
And, depending on whether it matters or not, sometimes it may not matter, but generally speaking, if, John's, pictures of John's refrigerator and the recipes that I'm going to make for dinner with my family, and maybe my credit card information will be stored, that's something you want to secure behind a login.
Mm.
And
Okay.
so tools are useful for doing that.
Okay, perfect. So we covered that. And then so now so we already did the data extraction. And then we did, I guess, like also for the data extraction, I think, how do we, like, are we extracting the recipes from the internet, or what are we extracting? And then how does extraction work? Is it just like, let's say I search fish and then they give me like 4,000 fish recipe, like from search?
So you can use, if I use the search components in this toolbox, I can actually find pages on the web that contain recipes that use the stuff that I have in my fridge.
Mm,
I will then be handed websites that contain those recipes. And in some cases, the search tools can actually give me sort of the recipe itself. But if you've ever looked at sort of cooking sites, they can have all different kinds of layouts, and it can be unpredictable exactly how to read the page.
mm.
So there are specialized tools for data extraction. I mentioned Firecrawl and Nimble and Parallel, and there's just a bunch of them
Yeah, yeah, yeah.
that look at these pages. And these are actually agents, Grace. They're just for developers, not for people. What they do is they look at the page and they reason about how to extract the recipe. And they say, okay, find the ingredients, find the steps, find the cooking time, find the photos of what it's supposed to look like.
Mm,
And they find all that stuff, knowing that they're looking for a recipe.
mm,
And they hand it back to the agent that is looking to present all this stuff.
mm. I have another question. So what's the primary difference between, let's say, if I use Firecrawl or I use Nimble or I use Tinyfish? Like, what's the differences between these like data extraction um tools? Is that they focus on different sector, or like did they program differently? I guess, like, what's a core difference here?
There are different approaches depending on how they go about the extraction. Some of them focus on, I won't get into naming names here, but some of them focus on being highly accurate for very specific kinds of data,
Mm,
and others focus on being really broadly applicable to
mm,
whatever it is you might want. Some of them are highly opinionated about the kinds of things you might like to extract from a page,
mhm,
and others are really broad and will let you sort of, you know, um, will let you sort of ask them to do whatever it is that you want to do.
mm,
And this is related but different to this other box that you're going to see called UI automation,
mm,
which is about not just reading pages, but is about interacting with them, taking actions on them.
mm,
And as you think about what an agent needs to do, the tools that it needs, the web is almost universally what developers say is the most important tool for them to be able to access. That's why you see things like, you see multiple boxes that are all about the web here. There's search, there's data extraction, there's UI automation, there's something called browser infrastructure that spins up,
mm,
lots and lots of different kinds of browsers
mm,
and in the cloud for your agents to access. So that's a really important area that agents want to be able to access.
mm. Um, okay. And then what about, we haven't talked about sandbox, secure tool, and all the data. I guess, like, we talk about storage. I don't think memory and ETL were covered yet.
Yeah. So
Honestly, the ETL thing is very popular these days because Llama Index, I feel like, is taking over in SF, but please keep going.
I would say that there's a couple things to mention. One is there's a sort of um, data has been and always will be a really important beating heart of any application.
Mm,
Okay, because how are the applications supposed to remember what it is that you did last time?
mm,
How are they supposed to know what is happening across your organization? How are they supposed to be able to provide you with the information that you need to make decisions? And so it's no different. It's just an evolution of the stack. ETL, things like unstructured and Llama Index and Reducto, are all really useful for uh, taking unstructured content, documents, whatever, and sort of reforming them into the structure that an agent can absorb, can use to make decisions. Traditional storage databases like Neon or MotherDuck or Supabase are all about long-term storage of the data. And this kind of tool has long existed, AI agents and usually even Gen AI. But it's becoming important uh, use use storage and be able to access and sort data and query data for the applications. So there was a great blog post from Nikita Shamganov, who's the CEO of Neon Databases. And Nikita said just a couple of weeks ago that AI agents are now creating new databases on Neon at 4 times the rate of human developers.
mm,
And the last piece is what we call memory. And memory is a great word for what's happening, which is about the agent reflecting on its day.
mm,
If John and Grace like to cook with a lot of, you know, bananas and apples and berries, it's not only going to remember that John and Grace like bananas and apples and berries. It's going to remember that John and Grace like fruit. And so by reasoning about the raw data and synthesizing on top of it, it can get more generalizable lessons that allow the agent to actually remember John and Grace even better the next time.
mm. Um, how about the model routing
Mm-hmm.
and agent routing and persistence? And then why is there a DIY section? I'm sorry, what is going on here?
Well, that's a really good question. I'm glad you asked. So, as I mentioned, the most simple kind of agent is a loop of prompt and response
Mm,
over some foundation model like Claude or GPT-4o. But actually, very few agents work like that now. Instead, they are composed of many sub agents that all do very specific tasks. And so those things need to be combined.
mm,
The agents need to be combined into a graph. That's the sort of agent routing world, and you see things like LangGraph,
mm,
which is from the company LangChain, and
mm,
from Crew AI, that's another popular one. Letta is a third. And so those are about specifying how the sub agents are supposed to work together and what it is that they're supposed to do.
mm,
For example, if we have an AI agent that's going to help us book travel,
mm,
one sub agent is going to be like the concierge that
mm,
sort of interacts with Grace. Another one is going to go look for flights. Another one is going to book flights. Another one is going to look for hotels. Another one is going to book hotels. Another one is going to retrieve, frequent flyer information. All these subtasks being done, and so agent routing supports that. at one level deeper, all of these agents may use different models or a combination of models. They may use Anthropic and OpenAI and Gemini and Llama and Nova and DeepSeek
Mm,
and S1 and whatever else. And so model routing is a technique that chooses the right tool for the right job and balances accuracy, it balances what each tool is best at, and things like performance and cost.
mm,
Persistence is an old requirement of any distributed system that just sort of keeps track of what's happening in the big picture. Now, with all these tools that are out there, what I see is that there's a lot of developers who kind of use these tools to prototype
mm,
and may not necessarily uh, be using all these tools in production.
mm,
And so there's a big DIY contingent at the orchestration layer today. I
mm,
don't think there's a best practice or a common pattern that has yet won.
mm,
And so that's something that I heard loud and clear. And when I do this kind of research, I speak to a lot of developers and I get sense checks. And a very common thing is, well, hey, there's a lot of cool stuff there, but I'm doing my own thing. And
mm,
so DIY is a tip of the hat to that kind of comment.
mm. Um, so essentially it's about, I guess, like the flow of using X to, like, I guess, using X tool to solve Y problem. And then essentially, and right now people could use the current agent routing tools or like model routing tools as like, you should use X because of X have the best accuracy or whatever, like based on what you need to do. And then it's kind of like a recommending agent or recommending tools. And then now, but people can also DIY. You can pick whatever you want to use.
Yeah,
Okay.
that's right. And people, this orchestration stuff, it is more awesome to be able to use somebody else's orchestration. It's more efficient. But if the orchestration isn't set up in exactly the way, with exactly the kinds of flexibility that I would want as a
Mm,
developer, I
mm,
might choose to create my own orchestration, my own persistence, my own, agent and model routing.
mm,
And so in those cases, I build it myself versus buying.
mm.
And so there are developers who are doing that today.
Wow. Okay. So, and then what about adding this back? So there's the PaaS and BaaS. So I know it's like platform as a service and backend as a service.
Yeah.
You want to share a little bit more about? Okay, so there's a question for John. We're gonna get to it in like 5 minutes. Okay.
Okay.
Hi, Shamel. Sorry, we'll get to it in 5 minutes. Okay. Oh, yeah. Okay, so let's, because I really want us to finish the graph. Obviously, we spent an entire hour chatting about your graph.
Yeah.
Um, okay, so yeah, let's talk about what, like, so for the platform section, how does developer interact with pass BaaS and
Yeah.
the
I mean,
side of things?
look, down here, this is where, there's a lot of battling still to come.
Mm,
Developers need to host their agent applications.
mm,
And the question comes whether they're going to use, you know, raw services from a hyperscale cloud like AWS or GCP or Azure or whatever, or whether things like Neon and Netlify and Supabase and Griptape and so forth are going to be able to provide all these, the underlying capabilities in a way that is idiomatic to what agent developers really want.
mm,
And just like, getting back to my point from before, Grace, a change in applications changes what the underlying infrastructure ends up requiring.
mm,
And so that creates this opportunity that really smart founders see.
Mm. Um, what is evaluation?
Evaluation is really important. It's I think Gary Tan said recently that the secret weapon of every successful AI application
Mm.
is really, really good evaluation. And a friend of mine extended that applies to the big model companies as well, where, you know, why is Gemini so good? Why is GPT-4o or Claude 3.7 so good? It's because they're really good at testing what good looks like
Mm.
and continuing to crank until the models are performing right, and until likewise app developers until the applications are performing right.
Mm.
So how do you do that? When these models and these applications are probabilistic, they're going to give different responses every time. How do you do that? And so there is a suite of tools that allows you to test it. And the most important part is the domain expertise of the creator of the app or the model that says, hey, what will be some common kinds of questions and what kinds of outcomes should I expect?
Mm.
And, you know, application developers that really focus on this are are typically the ones who build the best stuff. And while there are tools that are important, it doesn't get any developer off the hook from defining what it is that she actually expects her app to do.
Mm.
And that's her intellectual property, just like the code and the prompts and the architecture choices that she made.
Mm. So it's kind of actually evaluating if something is good or not. But like, what is a benchmark to evaluate if something is good? It's not just the speed and the accuracy, and then the accuracy have to be defined by, I guess, industry experts. How do you actually have a very, I guess like a good flow for like everything? Because like I feel like if you're building an AI agent in legal versus like other category, it may be very different, or like maybe building in the biotech space or something. I guess like what's a evaluation process, or like how does these like tooling stack listed here are gonna make sure that like something is working for every industry?
Well, it's not. The evaluation tools that we have allow you to specify what kinds of evaluations you want to run. But that choice of what evaluations you want to run is part of the design of the app itself. You can use, Gen AI to help sort of define those scenarios, but ultimately there has to be human input into what is the intent. If Grace is building an app, what is the intent of this app, and how will she know if it's working? And in a legal context, that's going to involve legal expertise.
Mm.
And so, in this cooking app, you can imagine a few different ways to see if it's to see if it works as advertised, right?
Mm. Very interesting. I personally feel like the storage area is like where it's the most, I guess, like active slash like, I guess, I don't know. I feel like I see like in your graph, I feel like I see all these companies everywhere. So like I'm not sure if they're like the most capital intensive, or not capital intensive, but like they're the areas that I guess like raise the most amount of money. But I guess my underneath question is like, which of these subcategory you are most excited about and why?
Well, the storage category under data is an ancient one that
Yeah.
is 80 years old and is continually reinventing itself.
Mm.
There's $100 billion TAM for data. It's only growing because the world gets more complex.
Mm.
And so, we're seeing that play out here. And as I mentioned with Neon, it's a traditional Postgres database, but happens to be really snappy in how fast it spins up and down. And that's useful for agents. So agent developers have started to use it. And so this is an example of an existing piece of the traditional infrastructure stack that has become super relevant for AI agents. And that will continue to be. There's another company on here that I'm a part of called MotherDuck, which is a serverless analytics database. And what's special about MotherDuck is it can be super efficient by balancing the compute between the cloud and your laptop. And if if data doesn't need to be computed in the cloud, it can be computed on Grace's laptop, which is a lot cheaper. But you have a supercomputer on your desk that you often use for email. And so that kind of balance is really powerful. And it's doubly powerful for AI agents that are spinning up and down constantly. Allowing agents to keep the cost low means you can have more kinds of agents delivered faster, a broader set of use cases, a broader set of business models. And so there's a lot of innovation that has happened in data that is now relevant for AI agents. That's one. Second, this world of tooling is something that's becoming a really hot area of innovation, because you can see just around the corner that as these AI agents start to become more sophisticated, they're going to need other capabilities that exist outside the capability of the model. I'll give you a clean example. There's a company that's actually not even on this map, Grace, called Resend Email. And you can think of it as sort of a next generation SendGrid. It sends email in a sophisticated and targeted way on behalf of developers. And developers are the customers for Resend. And Resend started seeing in January a huge spike in new developer accounts, having not launched anything or announced anything or done any marketing campaigns that were meaningful in January. Why? The answer is because Resend has a new cluster of customers who are not even developers. They're using Bolt. They're using Lovable. They're using Vercel v0. They're doing these sort of vibe coding things. And they specify when they're defining the app that they want to be created that the app should send an email under a certain condition. And so under the covers, Anthropic decides, okay, I'm going to spin up Resend Email. And so that creates all this demand at the infrastructure level. And so tooling, generally speaking, is something that is going to unlock a lot of capabilities. Starting to see that, poke through.
Oh, love that. Okay, so I don't know if I have one. Let's do one more question from the audience. So, Shamel asks, question for Jon: Is the future for business AI agent used mostly a local developed setup, consists of a mix of open source solutions for LLMs, workflows creations, or SaaS solutions? Just thinking of the sheer volume of confidential information that will be going through such solutions.
Yeah, so that's a good question I hear all the time. I would say that there's a balance of cost, latency, and regulation or policy about the handling of data that's going to define each agent setup in each context. There are some scenarios that require fully air-gapped AI agents. One of our companies is called EdgeRunner, and it's building AI agents for national security and defense. and those are fully air gapped. They're meant to run in forward deployed intelligence and military scenarios. But I would also say that having spent just under 10 years at AWS, Goldman Sachs and even the intelligence community are public about using the cloud for highly, highly sensitive information. And there are things like SOC 2 and virtual private clouds and all elliptic curve cryptography that says even the cloud provider doesn't have access to the keys to access the customer's own media. And so there are all kinds of capabilities that can keep information in the cloud protected to an extraordinarily high standard. And so on a use case by use case basis, there will be this trade-off of, what I sometimes call law of physics around latency, law of economics around cost, and law of the land around regulation and policy and corporate decisions about how to handle data.
Mm. Okay, so 1 minute fire round. What's your favorite book?
Night Flight by Saint Antoine Exupéry.
Who would you invite to your dinner party?
Who would I invite to my dinner party? I think, one thing that I really get excited about is people who are not yet famous and not yet prominent. I love meeting students, and I love meeting, really young people who are obnoxiously talented and have all kinds of bursts of ideas. I get to have dinner with lots of people who are already of fairly high profile, and getting to meet somebody who is not there yet is a very special treat.
Wow, I really like that refreshing answer. Okay, so who made the biggest impact in your career?
My wife.
Where can we find you outside of work?
With my kids.
Amazing. Well, John, thank you so much for coming on the show today. It was such a master class for AI agents. I'm sorry. This is great. Or I guess the entire flow. The developer stack for AI. Thank you so much.
It's a lot of fun. So great to see you, Grace, and thanks for everybody for your questions. Have a great day.
Let me quickly end stream. One sec.